The question number 110, that is the Zener diode is used as. The options are given below: amplifier, regulator, oscillator and the filter. When we connect a Zener diode in the forward biased condition, that is the positive terminal of the power supply is connected to the anode of the Zener diode and the negative terminal of the power supply is connected to the cathode of the Zener diode. That is called the forward biased condition. In forward biased condition, the Zener diode acts like a normal PN junction diode. If we connect a Zener diode in reverse biased condition, then that Zener diode acts as a regulator. Let us see how it works. If we increase the voltage up to breakdown voltage, then there will be some current exist in the Zener diode. That current is called reverse saturation current. This current exists due to the minority charge carriers. If we increase beyond the breakdown voltage, then there will be a drastically change in the current exist and this can be solved. This can be shown using the circuit diagram. What is regulation means? Even though increase in the source voltage, but a voltage at the load side will be a constant, that is VL is equal to Vz. If we vary the voltage means, if we give a 9 volt or 10 volt, 11 volt, but the voltage present at the load side will not increase or decrease, it will constant. See here, if we increase the reverse voltage beyond the VBR, the voltage will be a constant, that is Vz voltage, but current is drastically changes. So if we vary the source voltage, then the voltage present at the load side is same, that is Vz voltage, that is Zener diode voltage. So from the above option we can conclude that regulator, that is the third option. The question number 111, V naught is equal to minus 1 divided by RC, the integration of V in with respect to dt is an output voltage for. The options are given below. The first one is differentiator and the second one is integrator and the third one is phase shift oscillator and the fourth one is square wave generator. Consider this circuit. This is a differentiator circuit. Here at input side we are using resistor and at the feedback side we are using capacitor. This type of circuit is called differentiator. Here the non-inverting terminal is grounded, that means the voltage at B, is at ground potential. So VB is equal to 0. Suppose if VB is equal to 0, the voltage at node A is also equal to 0 because of virtual ground concept. Okay. Next consider at the input side, that is here the current which is coming from the input side is flowing through the input side, that is, and this current equation can be solved like this, that is I is equal to V in, that is voltage at the source side minus voltage at node A divided by R, because we know that VA is equal to 0. So we get I is equal to V in by R. Call it as this equation as 1. And we know that suppose a current which flows through the capacitor side, then we can write the equation like this: I is equal to C into dV divided by dt. This is the equation when current is flowing through the capacitor side. So the entire current which is coming which is going through the resistor R, that entire current flows through capacitor side because the input current of the op amp is 0. So at the output side, we get I is equal to C into d divided by dt, where V is VA minus V naught. Okay, then VA is at 0 potential, we know that. So this term becomes 0, so we can get only minus V naught, and remove that minus or take that minus term out of the bracket, then you get I is equal to minus C d by dt V naught. This is, call it as equation 2, and equate equation number and equation 1 and equation 2, you can get V in by R is equal to minus C dV naught divided by dt, and integrate on both sides. If you integrate on both sides, you can get integration of V in divided by R is equal to integration of minus C into dV naught divided by dt. That means integration of V in 1 divided by R, integration of V in is equal to the integration of differentiation is cancel out, so we get only minus C V naught. I am writing here what we get in equation, that is 1 by R integration of V in is equal to minus C into V naught. Then take this term in the LHS side, then you get minus 1 divided by RC integration of V in with respect to dt. This is the equation you get. From the option, you can simply tell that V naught is equal to minus 1 divided by RC, the integration of V in dt is a differentiator circuit. So the right option is differentiator. For the same DCET 2018 B series, we are going to solve problems on analog electronic circuits. The question number 142, the Bark-Hassan criterion for sustained oscillation is, the options are given below, that is A beta is equal to 1, A beta is less than 1, A beta is equal to 180 degree, and the fourth option is A beta is greater than 1. Before going to solve this question, first we have to know the Bark-Hassan criteria. The Bark-Hassan criteria is satisfied, then the circuit acts as an oscillator circuit. That means it produces oscillations. What it tells that, the first one is the total phase shift around the loop is 0 degree or 360 degree, and the second condition is the magnitude of amplifier gain and the feedback gain is equal to 1. That means if you give a signal, if you give a AC signal to the amplifier circuit, then you get a same AC signal. That means there is no phase shift. Here 0 degree phase shift exists between output of the amplifier circuit and the input signal. That is, at t is equal to 5 seconds, if we have a maximum amplitude, maximum amplitude, that means V max, then after the amplifier circuit, you should have at t is equal to 5 seconds a maximum amplitude. That means V in signal and the output of the amplifier circuit signal are in phase. That means 0 degree phase shift exists between output of the amplifier circuit and the input signal. And the part of the output signal is again fed back to feedback circuit. Here also a 0 degree phase shift exists between between output of the output signal and the output of the feedback circuit signal. Then there is a 0 degree phase shift between the output signal and the feedback circuit signal. Suppose if we have a signal like this, then output of the feedback circuit also you can get this type of signal. That means 0 degree phase shift exists between output signal and the output of the feedback signal. Then this feedback signal is again fed back to the input side. That means this signal is fed back to the input side. Here also you get 0 degree phase shift. That means from V into Vf you get a 0 degree phase shift. This is the first condition. Or it may be a 360 degree phase shift. That means if you give an input signal, then after the output of the amplifier circuit signal, if you get a inverted signal, that means here 180 degree phase shift exists between the output of the amplifier circuit and the input signal, and this part of the output signal is again fed back to the feedback circuit. That is, the inverted signal is again fed back to the feedback circuit. Here you can get inverted. That means 180 degree phase shift you can get after the feedback circuit. That means total 180 degree and 180 degree, around you get 360 degree phase shift between input signal and the feedback signal, or it may call it as a in phase signal. And the second condition is the magnitude of the amplifier circuit and the feedback circuit, that is the magnitude of the amplifier gain and the feedback gain is always equal to 1. Suppose if you give a input voltage is equal to 2 volt and amplifier gain is equal to 1.5, after the output of the amplifier circuit you get 2 into 1.5, that is 3 volt. You can get 3 volt because you are giving a input signal of 2 volt to the amplifier circuit. Here amplifier gain is 1.5. That means the output of the amplifier circuit you can get 3 volt. That 3 volt signal is again fed back to the feedback circuit. If you consider beta is equal to 1, that means 3 volt signal is fed back to the feedback circuit. Here beta is equal to 1. That means output of the feedback circuit you can get 3 volt. You are giving a 2 volt and the feedback signal is at feedback you can get 3 volt. That means the amplitude of the signal is increasing. If you are not giving a signal, then 3 volt is now is fed back to the amplifier circuit. Now your input signal becomes 3 volt, 3 into 1.5, because your amplifier gain is 1.5, so you can get 4.5 volt at the output of the amplifier circuit. That 4.5 volt is again fed back to the feedback circuit. Then output of the feedback circuit is 4.5. This 4.5 volt signal is again fed back to the amplifier circuit. Then that means your Vf becomes 4.5. That is, when A beta is greater than 1, that is, here you are getting A beta is 1.5. So in this type of signal you are getting a growing type of oscillation. You get growing type of oscillation when A beta is greater than 1. Suppose, next consider A beta is less than 1. If you consider V in is equal to 2 volt and A beta is equal to, the amplifier gain is, consider it as 0.5, then beta is equal to 1, then output of the, if you give V in is equal to 2 volt, then at the output of the amplifier circuit you are getting 0.5 into 2, that means 1 volt you are getting at the output of the amplifier circuit, that is at the output side. Then this 1 volt is again fed back to the feedback circuit, and this is multiplied with a beta is equal to 1, then you are getting at the output of the feedback circuit 1 volt. This 1 volt is again fed back to the amplifier circuit, then there is a no need of input signal, that is 1 volt you are getting, then again you multiplied with 0.5, you can get 0.5 volt at the output of the amplifier circuit. This 0.5 volt is again fed back to the feedback circuit, then you can get at the output of the feedback circuit as 0.5 volt. Then this 0.5 volt signal is again fed back to the amplifier circuit. That means here the amplitude of the signal is decreasing. As the time increases, your amplitude of the signal is decreasing. You are getting this type of oscillation. This is called decay type oscillation. Next we consider when A beta is equal to 1. If you give V in is equal to 2 volt and A is equal to amplifier gain is equal to 1 and beta is equal to 1, then at the output of the amplifier circuit you are getting 2 volt. Then this 2 volt signal is again fed back to the feedback circuit, then output of the feedback circuit you are getting 2 volt. Then this 2 volt is again fed back to the amplifier circuit, then there is a no need of input signal. Then this 2 volt is multiplied with the amplifier gain of 1, then you are getting 2 volt, and this 2 volt is again fed back to the feedback circuit, and the output of the feedback circuit you are getting 2 volt. This 2 volt is again fed back to the amplifier circuit. Here you are getting a constant amplitude oscillation, that is called a sustained oscillation. This is your sustained type of oscillation. So when A beta is equal to 1, you get a sustained type of oscillation. So from the above options, the first one is the right option, that is A beta is equal to 1. The question number 143, the primary function of a clamper circuit is, the options are given below. The first option is it introduces the DC level into an AC signal, the second one is suppresses the variation in signal voltage, and the third one is it raises the positive half cycle of the signal, and the fourth one is it lowers the negative half cycle of a signal. Before going to solve this question, we have to know what clamper circuit is. The clamper circuit is, it is a circuit which adds the DC voltage into a AC signal. Okay, suppose if you have a weak AC signal in addition to a DC signal, okay, if you pass this signal to amplifier circuit, what amplifier it does, it only amplifies the AC signal, but DC level, DC voltage is as it is, okay, it only amplifies, means we get a strong AC signal, but DC signal is same. Because the amplifier circuit, it only amplifies the AC signal, because in amplifier circuit we are usually using a capacitor. What capacitor does is, it only allows AC signal and blocks DC signal. So at the output of the amplifier circuit we are getting only a amplified AC signal. But if you want to amplify the DC signal, then what it does, you have to pass this signal through the clamper circuit. Clamper circuit. What clamper circuit it does? It will adds a DC level, DC voltage into a AC signal. Okay. In clamper circuit we have two types. The first one is a negative clamper circuit. Negative clamper circuit. And the second one is positive clamper circuit. In negative clamper circuit, if we have a AC signal like this, after at the output of the negative clamper circuit you get the signal like this. Okay. In positive clamper circuit, before applying to the positive clamper circuit, if your signal is like this, after output of the positive clamper circuit you will get the signal like this. Okay. So from the given option, the first option is the correct option, that is it introduces the DC level into a AC signal. Okay. The question number 144, an ideal op amp has dash input impedance. The options are given below. The first one is 1 mega ohm, and the second one is infinity, and the third one is 1 kilo ohm, and the fourth one is 0. If we know that the ideal op amp has always a infinite input impedance, that is Rin is equal to infinite. From the options, the right option is second one, that is infinity. Okay. Consider a op amp. Okay. This is your feedback circuit having the resistance R2, and this is a input resistance R1. This is a voltage source V in. If we give a input signal, then the current will flow through the resistor R1. Then this current will not enter into this op amp because of infinite input impedance. So the entire current will flow through the feedback resistor R2. The question number 145. In positive feedback, the amplifier gain is, the options are given below. The first one is it increases, and the second one is it decreases, and the third one is it becomes to 0, and the fourth one is none of the above. Before solving this question, first you have to know the feedback concept. What is feedback? Feedback, it is the property where the part of the output signal is fed back into the input side. Okay, in feedback we have two types. First one is positive feedback and the second one is negative feedback. We are going to solve or know the concept of feedback. Okay, consider a op amp. In that, this is your non-inverting terminal and this is your inverting terminal, and this is your output terminal. If the output terminal is connected to the non-inverting terminal of op amp, then it becomes a positive feedback. Suppose if you connect the output terminal of op amp to the inverting terminal, then it becomes negative feedback. But in this question they asked positive feedback. So this is the circuit of a positive feedback. Ground the inverting terminal of a op amp. Suppose if you give a 2 volt signal and if your amplifier gain is A is equal to 1, then here you get 2 volt, then 2 volt is again fed back to the input side, that is non-inverting terminal side, then 2 plus 2 volt is becomes 4, so it becomes continue, so it increases. Okay, the amplifier gain is increases. Suppose if you do some work, then someone will give a positive feedback for you, then your confidence level will increases. So similarly the amplifier gain is also increases when you give a input signal, that then you get a output signal at the output terminal, then that output signal is then fed back to the input signal, then it continues. So the amplifier gain is increases. Okay, from this option, the first option is the right option, that is it increases. The question number 175, the primary function of the filter is, the options are given below. It minimizes the AC input voltage and it suppresses the odd harmonics. The third one is stabilizes the DC level of the output voltage, and the fourth one is it removes the ripples from the rectified output. This question can be solved by using the regulated power supply block diagram. We are using this RPS in your laboratory. What it does, it will give you a constant DC output voltage. Okay, when you are giving a AC signal of 230 volt, the transformer, what it will do, it will step up or step down the AC voltage, but here we are using step down transformer, so it step down the AC voltage. Okay, suppose you are giving 230 volt of AC signal, here you may get 100 or 50 volt. Okay, then this minimized AC voltage is then applied to the rectifier circuit. The rectifier circuit, what it does that the AC voltage, the minimized AC voltage is converted into a pulsating DC voltage. The pulsating DC voltage means, in addition to DC signal, some ripples are present at the output of the rectifier circuit. Okay, so in order to remove that ripples from the DC voltage, we are fed back to filter circuit. The filter circuit, what it does, it removes the ripples. Okay, it removes the ripples which is present at the output of the rectifier circuit. We are getting like this. Although we are filtering that pulsating DC signals, we are getting still have the ripples at the output of the filter circuit. In order to remove that ripples, we are going to fed this signal into a regulator circuit. The regulator circuit, what it does, it will give you a constant DC voltage, and also it will removes all the ripples which is present in the regulator circuit. Okay, from this option, the fourth option is correct. That is, it removes the ripples from the rectified output.